Okay, sweet folks. So we've talked about now that community assembly is this process of dispersal and abiotic and biotic filters shaping establishment of species in new communities. We call this filter model of community assembly. And this is a predictable process, right? Part of the science of community ecology is understanding how this community assembly happens. And this ties back to some of the ideas we've talked about earlier in the course, specifically thinking about competitive exclusion, right? That we can predict the alpha diversity, the species diversity of a community, by seeing how broad the available niches are, or how tightly the resource specialization is of those species. And that competitive exclusion means that we are unlikely to have, the idea of competitive exclusion means that we're unlikely to have two species that have exactly the same niche, use exactly the same resources in exactly the same way, occurring in the same community, right? That's sort of where we're at in the mini lectures we've covered so far. I forgot, and then we talked about niche partitioning, right? We've talked about how there's sort of spatial niche partitioning, and that coexistence can happen among species that seem like they should competitively exclude each other because they may partition up the available resources. So they may specialize on foraging on a given part of a tree, for example, like MacArthur's warblers, or on specific soil types that are spatially partitioned across the landscape, like I told you about with those serpentine soils in California. There's another central hypothesis that predicts alpha diversity in communities and helps us understand why competitive exclusion doesn't mean there's very few species in nature. And this is the idea of disturbance and predation. Right? So we know, we've talked about this, right? That like disturbance can change the outcome of competitive interactions and pairwise interactions, right? So if we imagine a system where we have two species introduced to the community at the same time, species A is the better competitor, and we see that growing. Species B is a slightly less good competitor. It starts growing. Competition as A reaches high abundant levels starts limiting the growth of B, and B eventually becomes extirpated as A reaches its carrying capacity, right? This is competitive exclusion. But we also talked about how in a dynamic ecosystem where disturbances are happening all the time, that these competitive exclusion dynamics can be minimized, right? So you can imagine another situation where there's disturbance that impacts the most abundant organism more strongly, right? Let's say that, this is one species of plant, this is another, and as that really competitive species of plant takes over the landscape, there's a disturbance like herbivores eating, or there's a fire that burns the most abundant species, and this one that's less abundant isn't as effective. We can imagine a situation, right, where yes, there is that competitive advantage for species A, and species B, isn't doing as well. But then that disturbance knocks down A and knocks down B a little bit less. And then they both grow up, and then knocks down A and knocks down B just a little bit less. And then A and B, and you could see a situation where this kind of disturbance dynamic could maintain species diversity for both of these species, because the less well-competing species is never driven to extirpation or extinction, right? Extirpation is local extinction in a community. So in this case, the disturbance can limit the likelihood that the less competitive species is extirpated. This is true of predation too, right? Like a predator may prefer the more abundant prey species if these are two prey species, and it can act as a disturbance mechanism. It can act as, like I said, an herbivore breaks out and limits the strong competitor from reaching its carrying capacity, and allows the less strong competitor to stick around and not get extirpated. One of the central ideas about this is this thing called the intermediate disturbance hypothesis. Because let's imagine another situation. Here's the one I drew for you, right, where there's this disturbance that knocks them both down but doesn't extirpate either of them. Imagine instead it's like a freaking forest fire that burns the whole forest down. They're both growing, and then we have a massive fire and they're both extirpated. Now we need to wait for dispersal to happen again. Both growing, and then they're both extirpated. Now we have to wait for dispersal to grow again. That's a strong disturbance. In that case, strong disturbance can limit diversity. So we have a case where low disturbance limits diversity because strong competitors outcompete their weaker competitors. And a situation where high disturbance limits diversity because we constantly just have all of the species being wiped out. And then we have this intermediate disturbance, one that reduces the likelihood of less strong competitors being extirpated and maintains species diversity. This is called the intermediate disturbance hypothesis. This is an important idea in ecology. And it's been shown, disturbance, I guess I should put a space there, huh? Intermediate disturbance hypothesis has been shown in a bunch of experimental systems. Read your book to see. One cool one is that a lot of you I think will like is the idea of these sea stars that are a top-down predator, and they occur in some tide pools and not in others. And where they are present, we see higher diversity of lower trophic levels, right? So in this case, that predator is stopping the strong competitor from competitively excluding all of its competitors and increasing diversity. And if you wanted to draw a plot of the intermediate disturbance hypothesis, it would look something like this. We'd have something like richness or alpha diversity, right? Alpha diversity is just a measure of species diversity, so that can either be richness or it could be Shannon's or, Simpson's index or whatever. And then we have the level of disturbance. And we would expect a shape like this, a humped shape, where at really low disturbance, competitive exclusion happens. At really high disturbance, everything is extirpated. And at intermediate levels of disturbance, we have higher coexistence, so higher richness, right? That's the intermediate disturbance hypothesis. There was a second set of scientists, Menga and Sutherland, that brought in the idea of abiotic and biotic interactions, also driving sort of intermediate levels of these two things, driving high diversity. And the way this idea looks, let me make sure this door is closed so I don't get interrupted. The way this model looks is that at really low levels of abiotic stress, critical population rates of a given species are driven by predation at higher trophic levels, right? So here's a plot. We have stress here, right? And this is the relative importance. And I think this is like figure 19.6 in your book. Let me look. Let me take a quick look and make sure I tell you guys the right. 1919. Oh my gosh. This is relative importance, 1919. And at low levels of stress, this could mean stress or disturbance. Yes, 1 second. Oops, let me pause this, folks. I'll be right back. Everybody's home. Okay, we're back. That was CC for those of you that have watched the previous lectures and know her. So at low levels of stress or disturbance, the relative importance of predators is very high compared to other ways that limit population growth, right? Compared to physiological limitations, for example. But that as stress increases, the relative importance of predators gets lower. Alternatively, as stress or disturbance increases, the relative importance of physiological processes limiting populations increases, right? So the more stressful, the more disturbances that are happening, the stronger the effect those are on population growth rates, right? So predation is important at low stress. Physiological limitations are more important at high stress. And what that means is that somewhere at intermediate stress levels, the interaction between predation and stress means that diversity can be highest, right? That something like competition and all of these competitive cycles can become more important, right? And so we can see things where we can then use this sort of framework to understand, like, oh, in a given situation where stress is low, predators might be really important in maintaining diversity. In another situation where stress is really high, maybe the presence of predators isn't as important as the relative importance of stress. And at medium levels, maybe competition is really what's driving, alpha diversity in our communities, right? So that's right. Let's label these comp, phys, and pred. So the gist of this mini lecture, right, is that, okay, we have competitive exclusion happening often, but disturbance can sort of lessen the effect of competitive exclusion. It can mean that species aren't extirpated as quickly. One thing I want you to touch on that I didn't talk about here is this sort of Hutchinson's paradox of plankton. Read about this in the book. He proposed this idea that the relative times rates of disturbance and competition, so how quickly competitive exclusion happens versus how often the environment changes, gives us a good metric for how likely coexistence is to be, right? So if competitive exclusion happens really quickly, then environmental variability shouldn't be important because it happens too slowly. If the environment's changing really quickly and competitive exclusion happens very slowly, then maybe the environmental change is more important, right? So look at that in your book. I'm not going to talk about like TE and TC and the less than and greater than, but read that just so you know it. But yeah, that intermediate levels of disturbance, right? That environmental change, that disturbance, that predation can stop total competitive exclusion happening, stop local extirpation from happening, and can maintain high alpha diversity in communities. So this is one of those biotic and abiotic things that might shape community assembly. So I'm going to grab dinner, and I will finish these with you all in just like an hour or two, and we'll upload the rest then. See you soon.